All right, let's get started. So I'm going to try and do pagination from scratch. Let's see how it goes. And I'm going to be using limited offset to do it, Postgres clauses. And I'm going to be using the contacts starter project to implement it. So I cloned the project. And I'm looking at my database and I don't really have anything in there. So it's empty right now. So I can actually insert some random data in there. To kind of get a lot of data, fake data in there. So I'm just going to put in 1,000 rows. So now if I do a select star from contacts, limit 100, I have some fake data in here.
That's really cool. Sorry, I missed that.
I just added 1,000 rows of data into my database. So you can use generate series to create a series, and then because this is an array, this automatically uses the MD. You can use MD5 random to generate a random string, and because it's an array, it automatically generates 1,000 random strings. Okay, so now we have data in there. Let's start the server. So, so if I go here, I see a bunch of, so I see 1,000 contacts on a page, which isn't very nice, right? So now I want to add pagination, so I only see maybe 10 on a page, right? Okay, so let's look at the router for this page. So going to routes, index. So contacts.findAll is the function that is returning all my contacts, right? So this is essentially 1,000 contacts in here, and that's rendering the index page. Instead now, I just need to call a different function, right? Instead of find all, I want to find by page number, right? I need to create a new function. So going to my models, DB contacts, I have a find all here. Instead, I'm going to create a new function called find by offset. And then it takes an offset and limit, and it does some things. So let's do a query. So select start from contacts where one, limit 2, right? And then I would pass in the offset and the limit. And add the same error handling because I want to log. So continue to log my error message and then read through the error. So that way the person catching it above would display the right message to the user. So I just wanted to I guess there was, I was talking to some other learners yesterday, and there was a little confusion on how the catch works for, I guess why we have a catch and why we have a throw. Can anyone tell me why we're doing this? Why are we catching the error? And okay, so we could catch the error, that's a good thing, but why are we rethrowing the error? Helen, and then, yeah.
Console, to the command line, whereas throw throws it in the browser.
It throws it in the browser?
Yeah, it's an error.
It does not throw it to the browser. It just rethrows the error, but the question is why are we rethrowing it? So, yeah.
Maybe further down, then you can have a function that does error handling and displays a nicer message.
But what would happen if I just return the error instead? Would that work?
Aren't you going to stop the next function if you do that or something like that? Or I mean, or are you going to stop? I don't know. No.
So the one way that okay, Sally, you have.
Oh, so it knows it's an error. Phone, and the next thing you can catch it. If you return it, it's just the return value.
Right. So each function can take two paths, right? One is the successful path when things are good, and one is the bad path when some error gets triggered, right? And so when you're doing synchronous programming, you have this thing called try-catch, right? So when things are good, things in the try would be executed, and it would go all the way to the end of the try. But if an error occurs in the middle of the try, the catch block gets executed, right? So there's this fork where if something else bad happens, then I go to the catch block. But in the case of promises, since it's asynchronous, you have to use a dot catch on the promise itself. That's kind of like the fallback if something bad happens in the then. Right? So in our case, db.query is a promise, right? And when if I'm doing a dot catch without a dot then, I'm just handling the bad path right now, right? Which is if something bad happens, I want you to go this way, right? So I want my log to happen, but then somebody else is going to be calling this function, right? And if something bad happens, I need to inform that function above me to continue to go down the error path instead of going down to the success path. So as Sally was saying, that if I return the error, the person calling this function will assume that the error is the successful response. But instead, I actually want the function to know that this was an error. And the only way the function is going to know it's an error is if I rethrow it.
So is that almost like a long way of doing reject, basically? Because we think of resolve and reject.
Yeah, whenever you're throwing errors, it's essentially rejecting the promise. So this has to be thrown here. Right, so in my function here, if I say find by offset, right, and if there is an error which occurs, I want this catch to get executed, right? And this catch is only going to get executed when contact.find by offset throws an error. But if it returns an error, right, then it's going to assume that the error is the result of this function, and it's going to go into this path, and the error is going to be the value of contacts. And that's not what we want, right? We want the contacts to actually come back when it's a successful return of the query. But when something bad happens, I want this to get triggered. And this will only get triggered if this throws an error. And this will not throw an error until I explicitly, because I've already caught the error here, right? I need to rethrow it again. If I don't rethrow it, if I just return it, then it's going to go to the successful, because return it means that the function was good, whereas throw means the function was bad, like an error occurred. Does that make sense? Questions?
Why do you bother to console error?
Oh, here?
Yeah.
Oh, because I want to log like what were the arguments to this function, right? So when something bad happens, I have more information about what was the context during which this error occurred. So then I can look and be like, oh, for offsets like 2000 and 300, it doesn't work. So then I could be like, okay, then I know what to do. If it was just saying, oh, there was an error with like Postgres's, some weird exception thrown by Postgres, that doesn't give me the exact information about what were the values that triggered the error. Which is why I'm like logging arguments here. You see that, Danny?
Yes.
Okay. Cool, so this has to be a throw. Okay, so now that I have that, let's see. So I need to now return find by offset. And then in my contacts, for now, I'm just going to say find by offset. Oops. Is db.find by offset. And here, let's say find by offset is 0 and 10. Right, so if I do this, that means my values for, whoops.
Don't worry. Wouldn't it be, oh sorry, would it be 0, 9 or never mind?
Sorry, what is the question?
No, never mind. Yeah.
So the values of offset and limit are 2 integers, right? So I'm just giving it a default offset of 0, because you start from this. Actually, it may be 1. Actually, there's no 0.
Yeah, that's what.
For 1 and 10. So I want to limit the 10 results, and I want to start from the first row. So let's see if this actually works. No, it does not. And syntax error near offset. So here you go. So this is why. So this is the nice message that I get when something bad happens. Right. So if I didn't have this error message that I was logging, I would have just gotten this stack trace. Right, which is syntax error near offset, which doesn't tell me which query. So if you look at the stack trace of this error, it just goes to like something inside of my PG library, which isn't very useful. Whereas because of this log message, now I know error occurred while executing contacts.find by offset, and these are the arguments. So it's much more easier to reason about. Did you have a question, Helen?
Yeah. Can you explain more about limit and offset? Because when I did pagination with partners, we did limit 10 offset 1, and I noticed
Right.
we did limit 1 offset 10.
Yeah, so maybe that's what the error was. Maybe offset should come after limit. But let's look at it. So Postgres offset. Right, so limit comes first and then offset comes. Yeah, right. So limit and offset allow you to retrieve just a portion of the rows that are generated by the rest of the query. So limit tells you how many rows you want, and offset tells you at what position you want to start looking from. So this would now be switched. Let's switch this too. Right, so we swap those two.
I don't think there's a where clause either.
Oh yeah, that's right. Cool, thank you. And then let's swap these two. So we'll 10 and 1. All right.
There's an equal sign.
Yeah, is there any equal sign across?
Oh yeah, thank you.
And then, the two, the $2 the $1 for property assignment, does that switch too?
Yeah. Cool. All right, so So the values are, so I only got back one contact. So that means it's doing somehow a limit of 1.
Your inputs aren't matching what's in the array. The one
Oh, your
Oh,
offset
right,
limit.
okay.
The offset limit, yeah. Yeah. Actually,
Cool. So now we get 10. Right, so now I just have to change my my offset value. Okay, so
Where is used for something else?
yeah, where is when you want to filter things, but we are not filtering it. We're just using them as an offset. Okay, so the way I would like this to work is I would have like to say page is equal to 1, and then I get the first result, right? Can anyone see the URL? Page equal to 2, and I would like to get the second page, right? So that's the behavior I want. Page equal to 3, and I should get the third page. So that means that this route should accept a query parameter called page, right? So I would say const page equal to request dot query dot page, right? Or let's say is first page by default. So if I change this to page, actually, so this is actually just the page, right? So page into and let's say const limit is equal to 10. This is limit, and this I want to say is page into limit, right? So page into limit is what? So in the case when page is 1, I want this to be, okay. So what's the algorithm here? When, oops. So when page is equal to 1, I want my offset to be equal to 1, right? When page equal to 2, offset to be equal to 11. When I want page equal to 3, I want my offset to be equal to 21.
You want the offset to be 0 when the page is 1?
So yeah, I'm not sure if the offset starts from 0 or 1. Let's look that up. Offset 0. Okay, you're right. So this is 0, 10, 20. Right? So that means offset is going to be page minus 1 times 10. Right? Does that fit the formula? So
No, okay, yeah.
Yeah.
But it's going to be 0. Okay, perfect.
so in the first case, when page is 1, then you get back 0.
Yep.
Right? So we can say so we literally translate the formula, right? So page minus 1 into 10. And this becomes the offset. Right, so let's see if that still works. So page 1, page 2, page 3. Right, so now we're getting different results based on different pages. Okay, so
Should on line 9, should 10 be replaced with limit?
yeah, you're right. Good catch. So now you can just change the limit and then just automatically fixes things. Right, so now I have 20 results on a page. Cool. Okay, so now that we have that, we need to build. So I don't know how many people actually still use like those pagination with numbers. Isn't it now infinite scrolling? I don't know.
Infinite scrolling is the new thing instead of pagination.
Yeah, right.
Where you just scroll and then it does a little thing and there's more.
You have no idea how
The
many
bottomless
people there are.
pit. The bottomless pit. So what do you feel like doing? Do you want to do that, or do you want to do pagination? Okay.
We all hate it. Scroll.
Like scrolling into like
Oh, you do both.
Don't get greedy. Okay, so okay, let's do the pagination then. So we need to change the view now, right? So going to our page, we're entering contacts index. Right, so we have a footer, so I think we need to include partials pagination dot. Wow, that was weird autocomplete when I type a dot. So pagination.ejs. Right, so that would just contain all of my links. So I would now have partials, pagination.ejs. Pagination should come here. Let's put an H4. Right, so if I refresh the page, I get that there. Okay, so now, so how many of you have ever looked at this thing called explain analyze for Postgres?
Use something like that in other databases.
All right, so when I do a select star from contacts, do you think this is a good thing to do? Right, so it's literally scanning the whole table. Right, I have 1,000 rows in here. Let's actually make this table a little bit more crazy. Let's make it like 1,000,000 rows. So let's truncate table contacts restart identity. So I have 1,000 rows in here. 100,000, 1,000,000.
The identity.
Oh, that's resets the ID counter to 0. Otherwise, it would, it would conflict, right? Because I have a primary key attribute on that column. So cool. So select count of star from contacts. Yeah, we have 1,000,000 rows. Okay, so now if I do a select star from contacts, it's hanging. Right, so it took like a few seconds to do. So imagine if there's like 100 users on your system and doing this query, it would be crazy. So instead, what you can do is you can run this class called explain analyze on your query. It will tell you what's going on under the hood. So what it did was a sequential scan, which means that it went through the whole table to return the rows. And that makes sense because I am selecting all the contacts. Right? So it has to go through the whole table. There's no other way. It's kind of like, for example, when you're doing a binary search, the efficiency of finding an element is much faster, right? Because it kind of like goes half and half and only finds that one. But if you're doing a serial search where you're comparing each row, then the efficiency becomes O of n. Does it make sense? O of n, O of log n, these terms make a little familiar?
It's faster.
right? So binary search is faster because it is dividing the sequence and like finding the midpoint and then going this way or this way and then finding the midpoint. It assumes that the array is sorted, right? So based on what the element you're trying to find, it's going to like go and divide the row list of elements into like halves. So you finally get to a point where you cannot either find it or it doesn't exist. So binary search is much quicker. So what you can do here, so if we were to try to find something, right, where, let's say, so let's start from, so let's do this, where last name equal to, so it still did a seek scan on contacts. Right, so this is not doing a binary search. This is scanning the whole table. Even though I'm finding a single row, I still have to scan the whole table because it says rows removed by filter was 999,999 rows, and it just returned one row. Right, because the answer was just one row. Result is just one row. Okay, so why am I going into all of this? Is because when your table gets really big, you have to make sure that when you are doing your queries, whether you're sequentially scanning them or you're index scanning them. So now you can create indexes on your tables. You know what an index is? Anyone knows what an index is? Okay, so an index is kind of like adding some sort of a binary tree representation of a column. So, for example, let's say I'm trying to find by last name, right? If I create an index on a last name, then and if I'm trying to find a name which matches Eugene, right? So now it's sorted all of the names and created a tree out of them. So Eugene is somewhere going to be here because it's like, starts with E, but a name like, Sally may be here, right? Because it's like, S, so it's like on this side, whereas E is on this side. So sort of sorting names. So when you have to search for things, you only have to, again, it's a log n search, kind of like the binary search. So your efficiency becomes much more quicker. So if I have to say, find me all names which begin with E, it's much easier because then I just have to like drop down to the place where E is and just return those results instead of scanning the whole table and saying that does this name begin with an E? Does this name begin with an E? And scanning the whole thing, I can then just use an index portion of it.
So it's almost like you searched ahead of time and put it into.
Right. The index is maintaining a sorted order, unsorted representation of your data. So the converse of an index is that there is more space that is used by your database to maintain this index. And every time you insert a new row, this index has to be modified, right? So now there's an additional overhead of maintaining this index, but the gain is that searching is much quicker. So based on your app, if your app is doing a lot of searching and select star by this clause, then it's better to add indexes to those columns.
What size do you recommend starting?
If your app starts behaving slowly, you know that it needs an index.
How do you add an index?
Good question. It's called create index. So we can create index. So let's create an index on the last name, right? So if you're constantly searching by last name in our app, right? So sorry. So create index Postgres. So create index. So So there is this method called concurrently, which means that you can create an index without locking the table. Do you know what locking the table is? When you lock a table, when you're updating a table, Postgres locks it because it needs to add more stuff to it, right? Like, so if let's say I'm adding a new column to my table, right? Like there's a migration running and it's adding a new column. It technically has to go to each of the rows and add an associated column to that row because it's a new column, and you could have like a default value of the column, right? Let's say the column that we're adding was country, and the default value was USA, right? If that's the case, then while that migration is running, Postgres cannot accept new data to come in, because when the new data comes in, it's going to be confused. So what it does is for a defense mechanism, it just locks the table. So while that migration is running, you cannot add new data to it. And same thing with index too, because it's technically it's changing the table. But since indexes are slightly not directly contributing to the table, you can add it concurrently. But it's slightly dangerous because some bad stuff could happen. But there's an option to do it concurrently as well. So in our case, we're going to say create index on table. The method here is what kind of index you're going to use. So by default, B tree is the default, and that's what you're going to use, a binary tree. But there's like hash and a gin index and stuff. Don't worry about that. Most common usages are B trees. This is a binary tree. So we're going to do that. So let's see an example. So create index on last name. Actually, contacts. Contacts of last name.
We have an extra index.
Okay. So it will take some time because there are a million rows in there. So while this is happening, the whole table is locked, right? So because Postgres gives you an option of concurrently, then it'll do it in the background. But if let's say you had a migration which was adding this, and you had already a million rows in there, while this is running, nothing else would happen.
Does it re-index when you add data?
Yeah, automatically.
Automatically, okay.
So cool. So it's created it.
Can you define in the schema to just have a field be indexed?
Yeah, you can do that by default. So if I describe contacts now, it also has an index here. So contacts last name, it's a binary tree. Right, so now I can do this. Now I did an index scan. It took 0.4 milliseconds. And look at the previous time. Right, and it had to drop 999,000 rows. It didn't even have to like look at any rows. It just went directly down to that row. So it just looped once, in rows one. Yeah, that's it.
What's the tax associated with doing like a concurrent index?
What's the what?
Is there like a tax associated? Is there
Tax? Yeah, so the tax is like, there's additional data.
So it takes longer. It's going to take longer.
No, it takes more space, not more time. Because now you have to maintain more, there's more memory needed to maintain your index. Right, before it was just your table.
Were you asking specifically about the concurrent
Yeah.
index, like the words, like being?
Oh, the concurrently? Yeah, it just takes more time. Yeah. But ideally, you would want to use concurrently in production.
So when you were describing earlier, like when it creates these indexes, you gave the example of names where it puts like the E's in one section, A's or S's in like another section of the tree. Does it have, like, can you explicitly tell it to do that, or do you just create the index and then it figures out the best way to do that?
No, so the kind of indexes will, so the B tree index is used for that. It's like it's creating a tree. But you can also create a different kind of index, like, where did it go? Yeah, I mean, you can take some time to read about like the different kinds of indexes, but there's different use cases for different indexes. Like if you want to like search for, search across a string, a kind of, what is it called? Like text search. If you want text search, then you would want to use a gin index. But yeah, that's like a whole rabbit hole that I do not want to go down into. Cool. So now that we have that, I want to now say, select star from contacts, limit 20, offset 100. Right. So this gives me that. If I do an explain analyze on this, it's still so based on the kinds of queries, it automatically uses the index or not. So the Postgres is super smart to figure out whether it needs the index or not. So once you give it the indexes, it'll figure it out. Okay, so coming back to the pagination bit, we want to now have links, right? So the reason why I got into this is because now we want to know how many rows exist in our system, right? And based on that, we want to like come up with like how many links we would have, right? So select count of star from contacts. If I do an explain analyze on this, so it did a seek scan on this. Which is pretty bad, because every time you want to find out how many rows exist, it has to scan the whole table. So I guess like you don't really want to know how many rows exist in your table. You want to know like how many links do I need to put, because usually it's like 10 links, like it's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then it's like an arrow, right? Which means that you go to like 10 to 20, pages 10 to 20, and in the first time we would see pages 1 to 10. And if you click on the arrow, then you would go from pages 11 to 20, and then if you click the arrow again, 30 to 21 to 30, right? So we want something like that. So we don't really need to know how many rows in total. We just need to know if there are 1,000 more rows from the current point that I'm looking at, right? Which isn't too painful of a query. Okay, so let us, and also then we are assuming that the user would go down to like the, keep clicking until they reach the end. And that's probably very unlikely that's going to happen.
Why would you need to know the number of rows? Because if you, let's say, have, 10 search results, you would like divide the number of rows by the number of search results to figure out how many pages.
Right. That is for search results, but like for the page where there's no search results, and if I just have 1,000,000 rows, right? Or even if, yeah, exactly. So I don't want to spend that amount of time like just getting the number of rows I have in my system. Okay, so let's add some links here. So I want to have 10 links on my page, so pages 1 to 10. So how do I add a for loop in EJS? All right, here you go. So for, okay, so for I equal to what? I'm just going to copy this. So I less than, so I equal to, let's say, page start, I less than page start plus num pages. So page start is like at what page I am right now, and from the current page I want to go 10 pages ahead. Like I want to show 10 links, and here I would say a href equal to I, and then this would be I, and then in my here I have to pass in some extra data. So I have, so let's say I'm going to say const page start is 1, num pages is 10. Right, so page start and num pages. So let's see what we get. Okay, so I get page 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
What if you only have 5 pages?
Yeah, that's the problem we can solve in a bit.
Okay.
Okay, so cool. So it's changing the page here, right? So we're going to the 10th page. The problem is if I go to the 10th page, I still see the links from 1 to 10, right? I would want to see the links from 10 to 20. If I go to page 6, I want to see the links from page 6 to 16 or 15. So page start should be the page actually, right? So I want page start to be the current page. And num pages is equal to page start plus 10. Right, so that means that if I'm on page 5, my page start would be 5, and I would see pages. Oh, actually, no, num pages would always be 10. My bad. Num pages would always be 10 because I just start from 5 and then I go from 5 to 15 in my for loop. Because in my for loop, I'm already doing page start plus num pages. Right, so I always show 10 pages in my links. So if I go to page 6 now, oh no. Nice. So page start, what? Oh, is it because it's become strings here? So it's 609. It seems kind of crazy. 6 plus, what is the value of num pages? Page start. What? So 6 and 10. Yeah, so it feels like these are strings. So instead, I wouldn't say num pages here. I would say 10 class page start. Num pages is gone. Last page becomes last page is 106. Why is page start a string?
I think it's because when it goes to query that page, you return to string.
Oh, I see. Okay, so cards int of page. Okay. Cool. So jeez. Okay. All right. So we get pages 6 to 15, right? So if I go to the 15th page, I get pages 15 to 24.
Let's go to the second page from here.
Yeah, isn't it like how pagination works when you Google? Like, so you get the at least like some buffer between before and after the page, or this.
Yeah. So that's another feature. Yeah, we need to work on it. We haven't worked on it.
No.
Yeah. So now we have 10 pages. So now you're saying that we want links for next and previous, right? Or like, yeah. So we want page equal to some value, like foo, right? And we want to say, whoa. Okay, so something like that. Right, so then this is one. And then same thing here. Oops. Right, you want something like this. Right, so if I click on here, I should go to page 1. Well, this was. Right, we need these links. So these things have to be computed. Right now, they're static values. Right? So how do we compute them?
Current page minus something,
Mm-hmm.
or plus something. The last page plus something, and the first page minus something.
So in the case of when we are on the 10th page,
You just take the request query page and for the forward arrow, add 1, and for the back arrow, subtract 1.
so how would it work? So when I click on the forward arrow in this page, what would happen?
you would like it would go to page 11.
We'll go to page 11. Is that what we want?
Unless you want to go to page 20.
What is the behavior? What do we want? When I click on this arrow link, where should it go?
Page 22.
To the very end?
No, the next 10 links maybe.
The next 10 links.
Next time. So 22.
So 22. So 22.
29.
Gotcha. So this is just basically the last one plus one, essentially, and this one is the first one minus one.
Yeah.
So this becomes page start minus one. It obviously is not the right answer, but last page plus one. So in this case, if I click on this, it goes to 21. 32.
Oh.
So actually we want minus 5 here, because if I click on this, it goes like 5 pages this way. This looks kind of better. So it went to page 0, and that doesn't exist. So when we reach, so this we only say to show this if page start minus 5 is greater than 0, right? So we have an if condition. If page is, oops, wow, jeez. Is greater than 0. Then we do this. Then an end. How do we end an if statement?
Yes.
Oh, I guess we need like this.
Did you do a ternary there instead?
I guess we can. I'm just not a fan of ternaries. Something bad happened. Yeah, something is up with the syntax. Let's see. If
JS is the worst.
So if, and then it has a thing, and then it has an end. That's what I did. Oh, I have another bracket missing here. Cool. So if I'm on the page,
Oh, wait a minute.
yeah, if I'm on page 1, then I don't see it. If I go here, I see it.
You can't go back to page
Yeah.
1 if you're on page 5.
Yeah, there's something off with the math. So if I start with page 1 and I click on the last arrow, I need to go to page 5. Right? So let's say actually just page start. That's 5. Let's make it just based on page start. So if I click here,
Okay.
right? So this is much better. So 11 to 20. If I go back, I go to 6 to thing, I go back, go 1 to 10.
And what if you go to 4? And okay, so you still can't go back to 1 from 4.
Yeah. So Yeah, some math needs to change, but you get the idea. So so the question of like what would happen if I reach the end, right? If I reach 1,000,000 rows, then I do not want to show the next arrow. So then maybe there needs to be another property that comes out here, which is like more rows, is more rows. And this would be a query that you have to execute, which will tell me whether there are more rows after the current offset. If they at least, yeah. Does that make sense?
How do you do that? Do you have to have a separate query that tells you how many pages there are total?
No, not how many pages are total. That would be a very expensive query. You would have to say, given the current offset, and are there like how many rows after my offset? Are there 100 or are there only 50? So try to find the rows, 100 rows.
Would you have a separate SQL query for that?
Yeah, a separate SQL query, yeah.
Okay.
So basically it would be contacts dot num rows for num rows after offset, and you would give it the offset, which is offset, and you would give it the number of pages you want. So how many pages do we have on a page? You don't have a variable for that.
Page on a page, like.
Oh yeah, so that's 10. So let's say num page links is equal to 10. So this would be num page links. This would be num page links into limit. So that means this number is the number of rows that I want to ensure exist after my offset.
So counting the number of rows in a table is an expensive operation.
Yeah, counting all the rows, you have to scan the whole table.
Even if it's indexed?
Yeah. Because a count has to go through everything. Right? A search is limiting the number of rows you're going to return. But when you're counting, you have to go through the whole table. I wonder, Anyway, so you can potentially, there are many ways to fix that. You can have a cache of the count. So it's not always accurate to count, but that's still okay. And you can update the cache, run that. Because that query is a very expensive query. You can run it once every like 10 minutes or something, instead of running it every single time. So it would be out of date for 10 minutes, but at least it's better than like doing it every single time. Okay, I have a meeting at 10:30, so I have to stop. But hope this was useful.
Thank you.
Yeah, you're welcome.
Thank you.